Unit 1, Concept 3, we are dealing with compound interest, and our formula looks like A equals P times 1 plus R over N to the NT. And from the information that they give us, we can figure out our principal amount, our rate, and our time. So the principal amount was 8,400. The rate is 3.75%. We moved the decimal over to 0.0375. Our time, 72 months. So if we divide 72 by 12, that's 6 years. Our N is going to depend because we're looking for yearly, semi-annually, monthly, weekly, and daily. So that's daily, weekly, monthly, semi-annually, and annually. So that's going to be our N. That's going to depend. So our equation is going to look like P times 1 plus R over N to the N T. And our N actually could be X because that's going to depend on which X value we plug in. So we could put that in our calculator. It's going to look like this. When we have to remember that when we do the exponent, we put it in parentheses, and we put graph. We're going to trace it. Going to trace 365. And we round to the hundredths place, so that's 2 decimal points over. 52 12 get 105.82. Semi-annually we get 10497.62, we round. And annually 10476.30. So those are our answers. And Unit I, Concept 4, we are working with continuously compounding interest. So our equation is a little bit different. It's A equals P times E to the RT. And from the equation that we were given, our initial amount is going to be 6,800. Our time, we have a 9-month certificate, so if we divide 9 by 12, we get 0.75. Since that's just like a straight, that's it, 2 decimals, we don't need to put it into a fraction. Our rate, we move the decimal 2 over, so that's 0.0265. And we can set up our equation. A is going to equal 6,800 times E to the R T. We could plug this into our calculator. Our E, we have a button for. And so 6,800, and we put second E, and it gives us the parentheses, so 0.0265 times 0.75. we get 6,936.50. And Unit I Concept 5, there's 2 parts. So, for our first one, Ian invests $3,000 in an account that is compounded continuously. He's saving up for a trip to Jamaica, which he needs $4,000 for. So, what interest rate do you need to look for if you want to keep the money in the account for 3 years? So, we're looking for the rate. So, APRT. And we know that our principal amount, we invested $3,000. We want to get $4,000 in the end, so that's going to be the cost. Our rate, we don't know yet. Our time was 3 years. So our equation, we use the PERT. So A equals P to the R, which we don't know, T, which is 3. So we could divide, oh, we forgot our E right there. We divide by 3,000. 4 divided by 3, we get this long decimal, so we can change it into a fraction. It's the same thing, 4/3. So, to the RT. So we can use natural log to cancel out the E, since E is the base of natural log. The natural log of 4/3 equals 3x, and then we can divide by 3 on our calculators. So the natural log of 4/3 divided by 3. We get this number, and since our rate, we're going to need to move the decimal over twice. We write it as 4 decimal points. So it's going to be 0.0959. And we move the decimal to the right twice. Our rate 9.59%. So I don't know if we're going to find a bank that's going to give us 9% interest. So Ian wants to find a account offering a rate interest of 3.85%. How long must he leave the money in the account for? So this time we are looking for time. So we have a rate. So our time we don't know. Our rate was 3.85. So since we move the decimal 2 over, we get 0.0385. That's a decimal. And principal amount was the same as before, 3,000. And we still want 4,000 the bank. So we're going to do the same steps as the first one. So we set up the equation A equals P times E to the RT. 4,000 equals 3,000 times E to the RT. So again, we divide by 3,000. We're going to have 4/3 equals E to the 0.0385 times T. We use natural log. And if we want to find t, we just plug this in our calculator and we can divide by 0.385. So the natural log of 4/3 divided by 0.0385. We get 7.47. So 7.47, that's 7 years, and we need to calculate how many months exactly this is. So we can put 47 over 100 equals x over 12, since there are 12 months in a year. We can cross multiply 47 times 12 divided by 100 is going to be 5.64. So we can round this up. So we had 7 years and 6 months. So that's how long we're going to have to wait until Ian makes his $4,000 to go to Jamaica.